Welcome to Technology in Action, Chapter 5, System Software, the Operating System, Utility Programs, and File Management. So, we are starting off with Operating System Basics. The operating system is made of two primary parts. We have the operating system itself and utility programs that are built into the operating system. Now, the operating system does have a few different varieties out there. When it comes to PCs, we have three main options. We have Windows, Mac OS, and Linux. We'll come back to those in a little bit. When it comes to the utility programs, there are a lot of options out there, a lot of things built into the different operating systems. We will mainly be focused on the Windows ones in this presentation, but Mac and Linux both have their own specific ones that are, related to those. Now, your operating system has three primary functions. First, it's going to manage the computer's hardware. Now, as we've gone over prior to this, your computer's hardware includes the CPU, the RAM, the video card, the audio processing, the network interfaces, the video monitor, the keyboard, the mouse, the printer. It's managing all of that computer hardware, and it's making it so it's easy for you to understand, or for you to use at least. All right. It's also going to kind of provide teamwork per se when it comes to applications and working with the central processing unit. As we've kind of talked about before, your computer is great at doing one thing at a time. All right. Well, when you have multiple different pieces of software running at a time, you need to be able to distribute who gets priority and when and what's going on and those types of things. So teamwork and coordination are also kind of working together. And it's also going to be responsible for the coordination side of things with management and scheduling of different tasks. And taking inputs from your mouse or your keyboard or sending things to your printer and when this is going to happen and when that's going to happen. All right. I really like the little flowchart I have over on the right hand side of the screen. As you can see, basically everything in the user is a one direction thing. It sends information to the application sends stuff back to the user. However, the application is also sending stuff to the operating system, and the operating system sending stuff back. So this is basically all a two-way street. There's always information coming in and information being sent out. And it all kind of builds on each other. Without the hardware, the operating system won't do anything. Without the operating system, you won't have applications that can run. Without the applications that aren't running, the user has nothing to do. So it's everything is this two-way street where information's being sent all over the place, back and forth, and all sorts of wonderful things are happening. Alright, so the user interface. This is how you, the user, are going to be interacting with your computer. Alright, this is going to include things like your desktop, your icons, your menus, the terminal window, maybe even the mouse and keyboard if you want to get kind of crazy with it. This could be the touchscreen on your phone. All right. We're going to come back to some operating systems, some user interfaces that came prior to the one that you guys are probably used to, which is known as the GUI. All right, that's what you're used to, not the ones that are prior to it. All right. Yeah, so we have the desktop, which obviously is where everything gets laid out. It's what's on your computer screen. It's all the wonderful little icons on there that are allowing you to launch things and open programs and access the menus that you can then use to configure and tweak everything. All right. Now, the operating systems fall into basically multiple categories. So when they were first developed, they were designed for a single user performing one task at a time. All right, and this goes back to like a terminal screen, so where we would have just text on the screen and all you would have is a keyboard. You wouldn't have a mouse. That come later down the line. But all you had was a keyboard originally. And you would type in a command and you hit enter and the command would process and you might see text streaming on the screen to help you troubleshoot problems and things like that, or it might just blink at you and then a minute, 10 minutes later, whatever it is, it'd say, oh, results are done, here they are, and just give them out to you. All right, one user, one task. All right, now we're getting to a point where modern operating systems provide the ability to multitask. So you can have PowerPoint running, and I can have Camtasia running at the exact same point, so I can be recording my PowerPoint. Or you could have the web browser the web browser and Spotify or Word or PowerPoint or whatever else running at the same time. So that's going to be the multitasking capability. Having multiple cores in your computer nowadays is definitely helping with that, because your computer will take that and take this program and put it on core 1 and that program on core 2 and this program on core 3, and it'll start to try to distribute the load out to all the different cores, and the cores in theory then can process just that one application or 2 or 3 applications instead of the 10 or 15 that you actually have going in the background that you don't even know about. So multiple cores is helping with that process. And before we had multiple cores, what it did was it would run like a few lines of code from program 1, then it run a few lines from program 2, then a few lines from program 3, and it just kind of kept looping like that. So constantly like taking little nibbles at every different program that was running to allow it to seem like it was actually multitasking. So obviously multiple cores makes this processing better. It is pretty standard nowadays to have CPUs with 2 cores, even 4, 6, and we're starting to see it to become not standard, but it's available to the end user, to you and me. They're not like just big businesses where you can get CPUs that have 32 or 64 cores. So the number of core count is kind of skyrocketing. Now, having said that, the core frequency, 2.4 gigahertz, how many how many instructions per second the frequency of the core is running at is not necessarily increasing as much. So they're putting more cores onto a CPU, but they're not always going to have a higher frequency. So there's a little bit of a give and take here. Depending on the program you're using, it may have better single thread performance, so you may want a higher frequency, or you may want a more core count if you have better multi-thread capabilities. Now, we're also at a point where we have multiple users that can be using a single computer at a time. It's called virtualization, where you can have one computer which behaves like 5 or 10 or 15 or something like that. Or it's even just multiple users logging onto the exact same computer. Windows is not the best for this, for the multi-user aspect, unless you're virtualizing and doing some crazy aspects like that. But Linux is very well known for the virtualization. Windows Server, whole different game plan, but normal Windows not really meant for having multiple users logged on at the exact same time doing the exact same thing, or multiple things per se. Now, when it comes to your operating systems for personal use, all right, we have a bunch of different options. So, starting on the far left, we have Windows 10. This is probably the most used desktop operating system out there. Not specifically Windows 10, but Windows in general. Windows 10 is what we are at now, and I think it's supposed to be the end-all operating system for Windows. Basically, you're always just going to update Windows 10. There's never going to be a Windows 11 or 12 or 15 or something like that. We're just going to slowly keep updating Windows 10. Where we used to have Windows 7, and then we went Windows 8, we skipped Windows 9, who knows why, but we're now at Windows 10. Now, this is available on desktop computers, laptops, tablets, all-in-ones. You can even get smartphones that are running Windows. Now, there's not many smartphones out there running Windows, especially none that I know of that are running Windows 10, but there are still some available out there if you are a true die-hard Microsoft fan. Windows does have some specialty items or specialty configurations that help it when it's dealing with tablets and smaller resolution screens. So this is something to think about. So when Windows is dealing with touchscreens, it makes buttons larger and things like that. It's designed to make your life easier, and it's either will auto-detect if you have a touchscreen set up and you've gone into tablet mode, or there's a way for you to manually enable it. Mac OS is another desktop operating system. This one is only found officially on laptops and desktops or all-in-ones. All right. Traditionally, your Mac is probably going to be an iMac, which would be an all-in-one. They do have some desktop-specific versions of Mac, but those are normally much higher-end computers. Not necessarily high. I mean, they're going to have better performance, but they're not going to be just like a little better than the all-in-one. No, it's kind of like a large jump in performance most of the time. Not necessarily. And then they do have their own laptops, the iMacs, not the iMacs, the MacBook Pro, the MacBook, those types of things. Mac is, it's a good operating system. It really depends on what you're trying to use your desktop or PC for. Mac is traditionally favored by the artistic people, those doing with Photoshop, video editing, audio editing, graphic design, those types of things is traditionally the people who are in love with Macs. Just because you're not one of those people doesn't mean you can't use a Mac. It's just that's the ones that are traditionally going towards the Mac OS. Macs are, per performance, traditionally more expensive because Apple is the one that creates all the Macs. So if you buy an Apple product, you buy a laptop that has Mac on it, it is made by Apple. Where Microsoft is willing to sell licenses to whoever wants to build computers and install their operating system on it. So it's kind of two different processes. So just because you have a computer running Windows doesn't mean it was made by Microsoft. Most likely, it wasn't made by Microsoft. However, Mac OS, if you buy a product made by Apple that is a computer, not a smartphone or tablet, it will have Mac OS on it, and it will be made by Apple. So a little bit of a give and take there. iOS is the mobile version of Mac OS. All right. Still created by Apple. It's mainly for tablets and iPhones, and there are some iPod Touches still out there, which is basically an iPhone without some of the cellular connectivity. This is one of the more popular mobile operating systems. Android is going to be the most popular. Now, however, the iPhone is one of the most used phones out there. If you look per device, if you look at a specific iPhone 10 or iPhone X or whatever you want to call it, it might be the most used mobile phone out there, even though Apple doesn't have the largest market share. And that's again because there are very few Apple devices very few devices run iOS because it has to be made by Apple. Android, on the other hand, takes kind of the same idea as Microsoft, where it's you want to build a phone and put our operating system on it? Here's our terms of service. Go ahead and do it. There's not really any, there's control by Google, but there's very limited control over hardware out there. So Android is one of the more popular ones. We'll see that on the next screen. Android, smartphones, tablets, those types of things. Linux is another desktop software or operating system. It is on the open source side, so most Linux distributions or Linux operating systems are going to be free. And you can have laptops, desktops, or tablets of this. This is going to be one of the smaller groups of people who are going to use this. It is normally more of the very computer savvy because you can do almost anything you want on Linux, but it's maybe a very complicated way to do it. If you want your Linux to look like Windows, you can download a desktop system that looks like Windows. If you want to look like Mac, you can download a desktop environment that looks like Mac. If you want to install Mac on a virtual machine on Linux, you can do that if you have all the right stuff. Not quite sure the legality there. Probably illegal because of Apple's terms of service for the Mac operating system. But you can do it. There are many guides out there for how to do it. All right. And last on my screen, operating system-wise, is Chrome OS on the far right. This is Google's version, what they kind of picture to be the best mobile laptop-esque device. Operating system, I guess I should say. So, Chromebooks are laptops, or they call them Chromebooks. But they are running Chrome OS. So you can install Chrome OS on basically any computer that is meant for Mac or Windows, from my understanding. But it's really meant to buy a Chromebook as it sits. All right. These are normally going to be on the cheaper side when it comes to laptops. However, there are some restrictions like that. Mainly, they're limited to the Google app system. So you can install on most new Chromebooks, at least. You can install any Android app that is available. There are some other specific Chromebook applications types of things, but the glory behind the Chromebook is it doesn't need that much power to be operating because it's at its heart and soul, all it is a web browser. the goal here for a Chromebook is for you to use SaaS, or System as Services, not System as Services, Software as Services. So you're using like Office 365 or Google Drive or those types of things, and you're running everything in the web browser. So you don't need to have a super powerful computer that can run Microsoft Office or CAD or Photoshop or things like that. You're actually using the servers that are located somewhere else to do all the heavy lifting, and then you're just using your computer in front of you as a way to access those servers or use that processing power. So the glory there is because you're using everyone else's hardware, you normally can have a lower powered system in front of you, which helps reduce the cost for the end user, you. However, you still have the capability to get some very powerful configurations with i7s or i9 processors and things like that. However, there isn't really a need for that. Yeah, so those are your 6 probably most popular operating systems out there. Now here I have a map of the world, and with Android being green, Windows being blue, and iOS being red. And I believe this was operating system market share, like which one rules that specific section. All right. So as you can see, green and blue are kind of the all-out winners for who has the highest market share in specific areas. In the United States, Windows kicks butt. In Europe, Windows kicks butt. You go to South Africa, Android kind of takes over. So kind of a little bit of a give and take here. Whenever this graph was made, which was probably a few years ago at this point, and a few years ago that's from 2020, Windows had 79.24% of the desktop market, and Mac only had 14.64%. Chrome OS, which was probably pretty in its infancy when this was created, had 1.35%, and then all of the different Linux distributions together had 2%. If we go to the mobile section, Android had 85% of the market share, and iOS had 13.28%. So Android has the overwhelming control over the market. As I said though, however, one of the most used phones is the iPhone, because it is, if you're going to use iOS, you're using an iPhone basically. So 13.2, of that 13.28% of the iOS market share, basically 100% of that is an iPhone. So that's why the iPhone has one of the highest used devices, or most used devices. And I do have a link for where this came from, which was at like hostingtribunal.com, and then if you do operating system market share. Outside of Windows or Mac, Linux is another operating system that you can use for personal use, or you could use it for company use, which is probably actually where Linux is used the most on servers. We'll come back to that. As I said earlier, Linux is an open source system, and there are non-commercial uses for it. So if you want to say, screw you Windows, screw you Mac, I'm going open source with everything, Linux is a good option. Probably the only really option outside. Mac is actually briefly based, not briefly, kind of Linux-esque. There's some nice relationships there. So, open source, you can use this on your personal computer. I actually often have Linux dual booting on one of my computers because there are some things that are just nicer and easier to do on Linux. The other nice benefit of Linux is there's a lot of open source software out there that you can download for free that will do the same things you can on Windows. So it's not one of those things. They also have an app repository, as most distributions do, kind of like Android does or iOS does. So you can just open up a software and say, download this program, and it installs it and does everything it needs for you and all other fun stuff. So Linux has what they call distributions or distros, and this is the different versions of it. So this would be like Ubuntu versus Red Hat versus whatever other options there are out there. And there are a lot of them out there. So if you don't like Ubuntu, go ahead and try a different variation of Ubuntu. There's like Mate or Mint or Ubuntu Mate or Kubuntu or Xubuntu or whatever. Or you go to Red Hat or some other variation or some other distribution. When we talk about the platform, this is a combination of the OS and the processor and things like that that we're using. And that's the platform you are on. Remember, there are two very large, basically only two options for processors are AMD and Intel. As of right now, I think AMD's processors, the new ones at least, are kicking Intel's butt. However, Intel used to be the king, so it'll be interesting to see. I think this is one of those like ebb and flows things where AMD is kicking butt right now, and then in a few years Intel will be kicking butt again. So just kind of a little back and forth thing going on here. When it comes to upgrading your OS, it really comes down to, do you think you need to upgrade? Or is security an important aspect? In theory, as I said, with Windows 10, that is the last version of Windows, or there's always going to be free updates, or upgrades from Windows 10 to the next version of Windows. So it'll be interesting to see if that actually does continue. If you want to upgrade, is up to you in the long run. Windows does end support for their operating system. So Windows 7 security updates are finished. Windows is not creating any more of those at this point in time. So it's one of those things that it's like, well, if you want to keep making sure that your security and things like that, everything's good to go, then you need to upgrade your OS. Now, unluckily, that used to be meaning you had to pay Windows and buy a new copy, which could cost somewhere between probably $100 and $200, depending on which version of Windows you're buying. Now, as students, oftentimes you can get either a reduced cost or free version of it, depending on your school or where you're going on the internet or what you're buying. So that is something to look into. The other reason you might want to upgrade your operating system is for the new features. So Windows is offering, say, virtual desktops right now, which we'll talk about in a little bit later. But if that's something that's important to you, then maybe it's worth upgrading. And one of the other big questions is, does the operating system matter? All right, and the big question, the only question you have with does the operating system matter is, does the software you need or want to use work on another operating system? So if you're like, I must have Microsoft Office, you either need to use Windows or Mac. I do not know of Microsoft Office that is on Linux. However, there are alternatives on Linux like OpenOffice or LibreOffice, or there's probably some other ones out there that I don't know about. Now, like AutoCAD, it was originally basically developed for Windows, and AutoCAD has now started moving into the Mac market. I don't know of a Linux version of it. So if the operating system you use does matter, because it all comes down to what software are you going to be using. Now, with many softwares going into the SaaS or going into the cloud, operating system starts to matter less and less. All right, because as long as you're a web browser, you can probably access that software. I mean, you can do it from your Android phone, you can do it on one of the most powerful computers in the world, and you might not see that big of a difference, because if the server, wherever that is doing all the processing, your internet connection is actually more important than the actual connection or the actual power of your computer. If you're a really slow internet connection, it's not going to work. All right, so that becomes probably the more important topic for you, is what software are we using for your OS, not actually what OS is it. Many large companies are producing software for both Mac and Linux, not Mac and Linux, for Mac and Windows now. So between those two, it's really kind of a crapshoot. It's what one do you like better. But all it comes down to is the software available for you? Now, there is another version of an operating system called an RTOS, or a real-time operating system. And over here on the right side on the video, I do have a few options or a few examples for you. So we have at the top, we have a point of sale system, or POS, that you might hear it called POS. So this is when you go to like CVS or Acme or Martin's or Walmart or Target or wherever it is that you go shopping. There is a point of sale system there, and that is a real-time operating system. Alright, all it does is one task, and it does one task very well. We have industrial robots are running off real-time operating systems. We have hospital equipment running off real-time operating systems. Cars, those types of things. And the real benefit is that the real-time operating systems can have very precise timing. All right. If you think about how Windows work, and again, we've talked earlier in this video about how Windows used to kind of like push out like, okay, we're going to run a little bit of step A, and then a little step B, and then a little step C, and then a little step D, and then we're going to go back to step A again, or program A, B, C, D, right? Well, if you require very precise timing and something's happening and that program A needs to be reacting to, and the computer's working on program C, well, it may have missed whatever happened in program A. And if we miss something in program A, that could cause the robot to crash into the wall or whatever. Or for the operating system, it could cause the robotic arm or the ultrasound machine or the MRI or whatever it is to not work properly, because it sends a pulse out and it's waiting for that pulse to come back so it can actually get that reading. Well, if it's not accepting that reading because it's on a different program at that point, well, we got problems. So that is where real-time operating systems really come in and become the king. If you need something that's going to work very reliably, very quickly, at a very precise operating point, real-time operating systems is really the only way to go. Now, often a normal Windows computer will interact with that real-time operating system. In the robotics environment, you could have a normal Windows-based PC interacting with the controller that is controlling the robot, so you could actually see what step it's on or those types of things. Same thing with car engines. Again, if you're saying every time that this piston reaches a very specific position on in the shaft going up, then we need to fire the spark plug. Well, again, we don't fire at the right moment. We're either going to have very reduced power or no power of that engine at all, because it's not getting enough compression, so the fuel is not igniting, so we're not creating power. So little give and take going on there. Now, multi-user operating systems are going to allow multiple users to access the computer at the same time. All right. We have network operating systems, or NOS, and this is allows multiple computers to communicate, share files, and hardware devices with one another. In ATC 201, I believe it is, the computers that we had in that classroom are what they call VDIs, or virtual desktop infrastructures. All right. And this is kind of acting like a Chromebook, if you want to kind of like dive really deep into it, where all the VDI is doing, the actual hardware that you're sitting at, is interacting with a server somewhere, and that server is what's doing all the processing. It actually is running your version of Windows on that, and it's sending the information out to your computer over the network. And again, the main benefit here is you have one very expensive computer that can, say, have 300 people on it at a time. And you have, say, 20 classrooms that have 30 computers in it. Well, you've got 600 computers that can access that server. And as long as you don't have more than 300 at a time accessing it, that server is going to run perfectly fine, and you shouldn't see much problem as long as the network is good. But VDIs, I don't know if they're becoming more popular or less popular now. They were a big thing. I know HCC had a bunch of classrooms that had VDIs in them. And I think they're actually slowly starting to get rid of those VDIs and go back to normal computers. One of the big benefits of the VDI is every time you log onto that computer, it grabs the image for that computer. So it says, okay, here are the programs that are installed. And it goes and grabs it from a local file on the server. So when 30 computers all log in, they all grab that file and they say, okay, here are all the applications and things like that this computer has access to. So when a teacher like me says, hey, I need access to this software on my computers, they can go to one location, install it on one image, and then be fine. Where if I have 30 real computers in my classroom, they have to go to all 30 of those computers and install that software. So it's a lot quicker and a lot easier for them to manage one server location with VDIs than it is to manage actual computers. But the processing power and network infrastructure is kind of the downside. So it's always a give and take system when it comes to computers. Unix is a multi-user, multitask operating system that is used as a NOS. All right. So Unix and Linux, they're not exactly the same thing. They are, in the long run, kind of close. So Unix was derived from AT&T originally, AT&T development starting back in the 1970s at Bell Labs. So multi-user system, still used today for some things, but again, it's not the most popular thing that the average consumer is going to ever actually interact with. The user interface. All right. So how do we interact with computers? So the OS provides the interface that lets us interact with it. And what we use now is the last one, which is the graphical user interface. You might hear it called a GUI. It's pronounced Gooey, I believe. All right. So it has graphical displays, allows point-and-click technology with a mouse or touchscreen. It's a pretty way to visualize things. You know, it's very easy and intuitive for you to go, oh, I want to open this, and you just double-click on something. You know, and you don't have to know anything in the background. All right. However, where we originally was the command-driven interface. This top right, green and black. All right. So if we look at the very top of this, it says root at localhost ping-q fa.wikipedia.org. So they're pinging wikipedia.org, and they're hopefully going to get some response back saying, yes, I am alive, or I am here, or no, I am not here, those types of things. You can see they're doing a cd/var, which means they're going to go to the var directory. They're doing ls-la, which means they're going to list all of the files in the current directory, which is the var directory, and they're saying there's 72 of those, and it's telling us all sorts of information. So the command-driven interface, when you know how to use it, it is very powerful. However, it is very unintuitive because you have to know the commands that you are using. All right. Now, the big benefit to this is it's a very easy system to automate, right? As long as you know the commands, you can create a file which basically says, run this command, then this command, then this command, then this command, then this command. Where if you're trying to do it in a GUI, you're like, okay, click here, click there, click this, do that. And it's, you know, how do you tell the computer to click in very specific locations? So the command-driven interface is still used today. It's still a very powerful system for those who are trying to be what I'm going to call power users. Windows 10 has what's called PowerShell. This is the new version of the command line tool. It also has command line, which is CMD. So if you open up the start menu and you go to CMD, you'll get a black screen with white text where you can type out things to your heart's content. And hopefully you type out things that are, you know, the proper answers there. If you want to learn more about the command line interface and kind of start playing around with Linux, there is a little game at overthewire.org. That's overthewire.org, where you will learn a little bit about Linux, and you'll be accessing a server remotely via a command line, or a terminal is what Linux calls it. And it's, you know, it's a game where you're going to learn a certain command and you're going to try to find answers and passwords and keep progressing through the game. So it's kind of a fun way to, or a fun thing to go about doing. Now, but it goes back to one statement. As I said earlier, you need to know the commands. So if you don't know the commands, terminal is a very complicated system. So as a very low-level security system, if everything you do is based on off the terminal, it is actually a good way to secure your system from the average user. Now, any good hackers are actually working in the terminal. They're not working with GUIs, so it's not going to stop them. But having a terminal interface to do things will stop your wife, kids, whatever, unless they have started learning that from doing anything on your computer. So kind of something to think about. Now, to simplify things, we went from the command-driven interface to what was known as a menu-driven interface. All right, which is what I kind of have on the bottom here. The book had an even better picture in it, where they're showing you an older menu-driven interface. This is a newer one, but this allows you to choose the commands from menus displayed on the screen. So this eliminates the need for you, the user, to know every command. All right. So you're saying, I want to, print. You didn't have to know that you had to type print : / the print location of the printer, then the file you're printing. No, you just go, all right, I have the file open. I would go File, Print, and then hit OK type of thing. So the menu-driven interface was definitely a step in the right direction. Now, this was awesome. So this was, I don't know if this is when the mouse came around or if the mouse came around with the GUI interface. All right. Most of the times with menus, even in today, I believe you hit Alt button in like Office or things like that, they will give you the shortcut keys for different things along the top of the screen. So you still have that menu-driven interface option, and it allows you to say, oh, instead of me using my mouse, I can press Alt-D or something, and that will open up this specific menu or that menu or whatever it is. So the menu-driven interface, very powerful still. We obviously still use it today to simplify programs. They keep us from having so many different icons on the screen, but it's still not the most intuitive, because you have to know, okay, the menu option I'm looking for is under the bookmarks or under the tools or under the file, or where is it located? So it's still not the most intuitive based system. Previously you had to use, you said it was all shortcut based, so you hit a button that would bring up a menu, like you pressed F and it bring up the file menu, or Alt F or whatever, and then in that file menu there were different words, and like certain letters were capitalized or bolded in that word. So like if we looked at here, you'd have like the T in toolbar would be capitalized. Where's my mouse? There we go. The T in toolbar would be capitalized, and the S in status bar would be, and then maybe the I in sidebar would be. So if you wanted to open the toolbar, you'd hit T, the status bar, you'd hit S, and if you wanted to open the sidebar, since S was already used for status, you'd hit I for sidebar. So there would be like a specific letter, capitalized, bolded, both, whatever, that would tell you that's the shortcut button. So, now, truthfully, command lines or menu driven are actually going to be a quicker way to interact with your computer than a GUI environment. All right. If you think about it, the issue I just had a second ago, where's my mouse? If you have command line or menu driven, you don't care about your mouse if there are keyboard shortcuts for everything. So you can move through a menu-based or command-based system much quicker using just the keyboard than you can if you have to use a mouse, if you know what you're doing. CVS, their old system for printing labels and dealing with counting the money and entering sales and all other fun stuff, was basically a menu-based system. There was no GUI to it. You had to be like, okay, if I press the tilde button, it brings up my different screens, and then I can press this to get to the counting screen, and that to count the money, and you use the tab button to go from one field to the next field, and things like that. And once you got used to it, it became second nature. It became really quick. And the glorious part was, you didn't have to take your hands off of the keyboard. Think about in a GUI environment. If I want to go click on the T, I'd have to find my mouse wherever it's located, go find the T and click on it. Or if I'm going back to this menu-based system, if I have to go to view and then character encoding, then UNIA code, I have to go click view, move my mouse to character, then move my mouse to UNIA code. Where if I know all the shortcuts, I could go like Alt V for view, C for character encoding, U for Unicode. So it's 4 or 5 button presses and it's done. So you don't have to move your mouse around. You don't have to move your hand from the keyboard to the mouse, back to the keyboard, back to the mouse, and constantly jumping back and forth. So menu-driven interface is a much quicker way to be doing things. This is also why we have shortcut keys. And again, that's to save you time. If every time you wanted to copy something in Word, you had to move your mouse to that top left-hand corner and be under the main tab and go copy, it'd take time. Where if you have your left hand on your keyboard, you can do Control-C, Control-V, Control-X, and those types of things to copy and paste. It just saves you a lot of time. You'll probably notice that a lot of shortcuts, keys, and things like that you have for computers is based on your left hand. Because most people are right-handed, so if they have their mouse in the right hand, they have their left hand still resting on the keyboard, they can do a lot of different shortcuts without moving their hand very much. So Control-Z, V, X, Control-S for save, caps lock, those types of things. It's all right there by your left hand, so it actually saves you a lot of time with a menu-based system. Hardware coordination. How does your computer know what it's supposed to be doing and when it's supposed to be doing it and who wins? All right. So how it knows or what it should be doing. All right. So first we have events on your computer. All right. Every keystroke, mouse click, signal to the printer, Blu-ray, signal from those devices to the monitor, from the temperature sensors, whatever it is, every little piece of information the computer gets basically is some sort of event. All right. Without those events, the computer doesn't do anything. All right. Then that's going to take us to the interrupt handler. All right. So each device has its own type of interrupt, which is associated with an interrupt handler. And that is a special numerical code that prioritizes the request. So what is the most important thing happening at this point in time? If you're saying processing is the most important, don't care about anything else, well, moving your mouse wouldn't move the mouse on the screen. You move your mouse and nothing would happen. It's kind of like when your computer freezes because it's like, I don't know what's going on right now. So mouse and keyboard inputs don't always do something. So that type of thing. So over here on the right, we have a little bit of a process going on. And this is going to be like a little bit of preemptive multitasking, basically. All right. So these events that are placed on the interrupt table from the interrupt handler are placed into a table in the computer's primary memory, which would be the RAM, which stands for random access memory. Quick reminder. All right. And the OS processes the tasks assigned a higher priority before processing a task assigned a lower priority, and that is what's preemptive multitasking. So you have your mouse movement. That's probably rather high on the priority list because you want to, if I move my mouse, you want to see your mouse move. So that's going to be more important than, say, playing a video or printing or those types of things. So if the required resources are already in use, the request will be put in a buffer until the required resources are free. All right. And this is going to lead us to what a spooler is, which is a program that helps coordinate all the print jobs currently being sent to your printer. So if you're trying to print 12 different items to your printer, it's going to go into the spooler, which kind of creates a queue and tells the printer, print this page, then this one, then that one, and all those other fun things. Now, the little image we have here on the right. So we have it saying the CPU is playing a movie. So you're watching Spider-Man or Jack Ryan or whatever movie, video, YouTube video, whatever it is that you are watching. All right. At this point, your computer receives an error request from the printer, basically saying, "Hey, I need to print something." All right. So that's step 2. Step 3, it's a memo about the movie. Is stored in the stack. So it says, "Hey, I was playing a movie. Let me put that on hold for a second." So it puts it into the stack. Step 4, the CPU starts executing the printing. So it says, well, I need to actually print this document now. So send this page, send that page, and this page, basically. And then once we're finished printing, or at least once the computer's done sending information to the printer, it goes back to the stack and says, "Oh, that's right, we were playing a movie." And it says, "Hey, computer, play the movie again." So that is kind of the basics of the multitasking. And whether that's just running multiple programs at the same time, again, we're going A, B, C, D, A, B, C, D, and it is putting the different programs in the stack and then going back to them later. And again, you have different priorities. So it's saying, hey, this is the most important priority. And priorities could change. You could be saying, well, printing's the most important right now, and then something else really important could happen, and you'd be going, all right, printing's got to go on hold for a few minutes while we process something else. So hardware coordination is that's keeping your computer going. You have to have the events, you have to have interrupts, because without interrupts, we can't actually do anything with the events. We can say that, well, the events are happening, they could be piling up in a queue, but if we don't ever tell the computer, hey, this just happened, it's really important, the computer never knows to go check that queue. It's probably doing something else. So, all right, this then leads us to the memory and storage management. All right, your computer has RAM in it, 4 gigs, 8 gigs, 16, 32, 2 terabytes. All right, if your computer has 2 terabytes, you probably have more money than you know what to do with. I wish my computer had that much RAM. I wish I had that much money to just be wasting money out the window. However, I don't. All right, my computer has 16 gigs of RAM, which is plenty of RAM nowadays, unless you are doing some super crazy intensive projects, or you're like, all you ever do is leave all of your Chrome tabs possibly open at the same time. All right, so something to think about. However, when you get to the lower end of the computer market, when you're buying a cheap computer because your computer crashed, and might buy a nice one, you might be buying a computer that only has 4 gigs of RAM. And that is definitely pushing what I would qualify as the minimum number of RAM nowadays. If I'm buying a computer, 8 gigs would be what I'd want in that computer at a minimum. I would prefer 16. Is 16 absolutely necessary? No. 8 gigs will probably do just fine for most tasks. Now, recording videos, video editing, Photoshop, CAD work, those types of things, having more RAM will be helpful for you in those situations. All right. Now, when you run out of RAM because you only have 4 gigs in your computer, we have what's called virtual memory. All right. And what that is doing is it's borrowing room on your hard drive for use of as RAM. Now, as you guys should remember, RAM is extremely fast memory. Spinning disks, or spinning rust as some people like to call them because they are metal, is extremely slow comparative to RAM. So there is a bit of a give and take going on here as of what's the more important, or why would you want to use that? Well, if you need to absolutely require more RAM space, that's the only option, is to say, okay, I'm going to use my hard drive. Now with SSDs, if that's what your hard drive you're using, that is a much better option for using as your virtual memory than a traditional hard drive. So a little bit of a give and take going on there. However, SSDs only have so many read-write cycles, so using it as virtual memory is going to possibly damage your hard drive much quicker than traditional use would. All right. Now, as part of that virtual memory, we have what's called a swap file. And this is a file on a hard disk used to provide space for programs which have been transferred from the processor's memory. All right. And part of that swap file is paging. And this is when we move data from the RAM that hasn't frequently been used to the swap drive, or to the swap file. All right. So basically you're saying, well, I've got 4 gigs of RAM, I've got all these programs open, or I have all these Chrome tabs open. You know, you have 50 tabs open. I don't understand how people can have 50 tabs open. Having like 10 drives me nuts. But some people just like constantly go around rabbit holes and they just go, let me open that in a new tab and save that one in case this one doesn't lead somewhere good. And they just keep, you know, link to link to link to link and opening more and more tabs. You have like 50 tabs open. Well, Chrome or Firefox or whatever realizes that you're not actually actively looking at all 50 tabs. So it's trying to save some of the memory, and it's trying to basically take the files that are open that you're not actively using or haven't used in the last 5-10 minutes, whatever, and basically it's going to put them in page, all right, or put them in your swap file in your virtual memory. So it's going to say, this might be important a little bit. It's not the most important thing right now. Let's use the RAM for something more important. So it's going to take the Chrome tabs that were open and store them in the page file, which will be quicker to access than probably re-downloading them from the internet. But it still allows your RAM to be used for more important things. All right. Now, if you're going to do if excessive paging is happening, not if you're choosing to do it, that is what is called thrashing. So if you're like, okay, take this and put it in the page. Oh, now take this and put it in the swap file. Now this in the swap file. So you're always like actually actively using all 10 applications on your computer. But it's trying to use whatever one's open to put that in RAM. That is thrashing. So you're basically, you truly need more RAM. All right. Now, as I think I told or mentioned before, upgrading to a solid-state hard drive and putting more RAM in your computer for an older computer, we're talking like 4 years old at this point, maybe all you need to do to make it feel like a new computer. All right. Because most of the time you're not actually hitting processor limits if you have a older computer. You're having normally the hard drive or the speed at which you're accessing stuff is what's making it feel slow. So putting a new SSD in there that has 15 to 100 times the access speed of the hard drive or greater, putting more RAM in so you don't have to go to this virtual memory and having paging going on, those things will just make your computer feel so much faster that it'll make it feel like brand new again. And I have an older laptop here that we put a new hard drive in, and just that made a big difference. So it is probably worth the $50 to buy a 128 gig hard drive SSD and put it in your laptops if it's like 4 years old at this point, instead of having to go out and buy a new $400 or $500 computer. So something to think about. Most newer computers are coming with SSDs in them nowadays, so you're not going to get this upgradability in the future. But this is something that like large companies are doing to bring back whole computer labs or things like that, so that it saves them 1 year, one turnaround. I believe a lot of companies have like a 3 or 4 year computer replacement policy. So they're getting away with this time with just upgrading RAM and RAM and hard drives, which instead of having to buy a $500 computer, they may be putting $100 in and getting another 3 years of life out of it. So completely worth it in their opinions. Your computer has a file system on it. All right. Has to do with your hard drive and how it is formatted and what type of data and things like that that it is expecting. And on the screen I have a list of all of those different options. I think most of this came from reclaim.com, so reclaime.com/library/file systems types. Something that you might want to go look into individually. I believe most Windows-based systems now, so Windows 7, 8, 10 are using NTFS as their option, which is that third option on the left. This allows you to have file sizes or max hard drive sizes up to 2 terabytes is what this is saying, and that might be a little outdated at this point. That might be able to be bigger. But like if we go back to the original, Windows used to be on FAT16, FAT32. So like a FAT16 formatted device, flash drive, hard drive, whatever, the max file size you could put on it would be 2 gigs. And the max disk size could be 4 gigs. So like if you had a 100 gig hard drive, you cannot format the entire thing as one partition of FAT16. You'd have to have 25 4 gig partitions, which would get very annoying. FAT32, on the other hand, has a max file size of 4 gigs, with a max system size of 2 terabytes, so a much longer. I said these are all different ones. HFS is Mac OS standard. HSS Plus is the Mac OS X extended. So that would be the default file system on Apple computers and other complex devices like iPads. APFS is the Apple file system released in 2017 and came to replace HFS Plus. You have EXT, which is different for your different versions of Linux for generations. You have EXT 2, 3, and 4. You have XFS, which is the file system used in Linux installations and NAS devices. So all of these are different types of file systems, and they're going to be different places and things like that. This also might be why you can't interact with a specific flash drive you plug in. If a flash drive is designed for an Apple system, Windows may not be able to read it, or if it's a Linux-based system, Windows may not be able to read it. So it's very important to make sure that the type of file system you have is something that you are able to access. So especially if you are passing information from you to your friend, to your coworker, to whatever, you want to make sure that you pick a file system for like your flash drive that is accessible by all the different devices that you may be using to access it. Hardware, your phone, mouse, keyboard, flash drive, printer, whatever it is, needs to have a way to communicate with whatever device that it is connected to. All right, and we do that using drivers. And basically what a driver is it's a way to communicate between whatever device it is and whatever operating system it is being used. Some devices have very complex drivers that you have to like specifically go download. Sometimes Windows can, when you plug a device in, can go out to the internet and find that device, download the driver for you, and run it. It really comes down to the company who made the hardware, where the drivers kept, those types of things. So you do need to be careful about, like, especially with questionable drivers. Like, you're like, oh, I got this hardware, and you're like, I don't know if I really trust this website, and it's the only way I can use this. Or you bought a piece of hardware and it comes with this CD, and you're like, I don't know if I really trust that CD that has the driver not have a virus or something on it. So you need to be a little bit careful with your drivers and things like that. Now, many devices now are plug and play. So this is a software and hardware standard designed to facilitate the installation of new hardware in PCs by including the OS, the drivers including in the OS the drivers these devices need in order to run. So like a mouse, you can basically plug any mouse into any Windows computer. Maybe not all of them, but any basic mouse into any Windows computer, and without having internet, it will get the mouse up and operational because the driver is already installed. So flash drives are another example. You don't have to go and say, oh, I've got a Microsoft flash drive versus a no-name versus whatever other brand flash drives there are. They all have plug and play. So basically you plug it in and it goes, okay, this is how I communicate, and it says, all right, we're good to go. This is a flash drive. Now, you might want to update your drivers because that may increase reliability, decrease some lag time. Like, if you moved your mouse and you've actually moved your mouse and then stopped, then you finally saw the mouse move. That could be a driver issue. Your drivers could be causing your computers to crash or cause problems. So there are all sorts of issues that we have with drivers, and drivers are probably one of the most important part of the computer, because without them we can't interact with devices outside of the computer, like a keyboard or a mouse or anything like that. So you do need to be a bit careful when it comes to your drivers. Now, Windows does have a rollback feature that removes a newly installed driver and replaces it with the last one that worked. All right. So this is a system that you would use if you had problems with your device. Like you plugged it, if I plugged the new mouse in and everything was working fine, then it's like, oh, there's this new driver that increases security or whatever the purpose of that driver is. You go, okay, go ahead and install it. And then all of a sudden it stops working. You can roll back your driver. Up on the screen I have Device Manager showing, so this lists all the different categories of devices that are plugged into the computer and all of the different devices within inside those. Now these two pictures are not the same picture. They're two different ones that I put up on the screen, so that's why they don't make a lot of sense. But as you can see here, we are under the network adapters one. We have a Hyper-V Ethernet adapter, we have our Gigabit one, we have a Microsoft one. If you had a wireless one, that would show up in here. If you had Bluetooth, that would show up in here. Any keyboards you had plugged in would be under the keyboard. Any disks would be under disks. So even your hard drives have drivers associated with them. So after you would right-click on ones that you're having a problem with, you would go to Properties, and then often it either opens to the General tab or the Driver tab. And here you can say there's an Update driver button that you can press, and you can say Search Windows Update for it, or you can say Update from this specific file. You also have the Rollback button if your driver stops working for some odd reason. So you could say, okay, let's go back to the last version that worked. So something to think about. Now, drivers are a way to interact with hardware. APIs, or Application Program Interfaces, are ways to interact with software. Now, these are traditionally used by computer programmers. They're not going to be used by the average Joe. All right. APIs, or Application Program Interfaces, are blocks of code that the computer recognizes. And what this allows us to do is to reuse the same section of code multiple times. So instead of having the same blocks of code for similar procedures in each program, the OS includes the blocks of code and allows the software to then access it. So an example of this would be Microsoft DirectX, which is a group of multimedia APIs built into the Windows OS that improves graphics and sounds. All right. So it's basically similar procedures. So, it's like, how do I display something on the screen? Well, I could write code that says, draw a box from point A to point B, or I could say, go to Microsoft DirectX, so just call DirectX up and say, draw a box from point A to point B. So it's like one line of code that I have to type instead of me having to write 100 lines of code to do it and then call it myself. So it's a way of accessing software. Now, some companies build in APIs into their program for the end user to use, so they can create things like apps. So if you wanted to, if you had, say, like Microsoft PowerPoint, you could download an API maybe for it, or there might be an API for it, that you could access from your phone to use your phone as a remote to control it type of thing. So you basically write an app that says send PowerPoint this command, and PowerPoint would say, oh, okay, move to the next point, move to the next point, move to the next point, or show the notes on the screen, or whatever the topic is. I actually used an API on my 3D printer to add an external display to something. So instead of having to use a web browser to control my 3D printer, I had a little screen and 5 buttons that allowed me to say, turn the print bed on, heat the print bed to a certain temperature, yada, yada, yada. So it allowed some extra capabilities on the system. The API is not restricted to the OS. There's a way to access someone else's software from your own. So not just the operating system operating software, accessing the software. It's not the software just accessing the operating system. If the API is public, you can write your own code that then uses someone else's software to your own purpose. And I mean, that's a wonderful thing. Now, when it comes to booting your computer, there are 4 main steps to this. All right. The first step is to activate the BIOS, and BIOS stands for Basic Input and Output Systems. All right. This is permanently stored in the ROM, or the read-only memory, on your motherboard. All right. So this is a chip that in theory doesn't change. It does not forget when you take power off, those types of things. The BIOS is going to manage the exchange of data between the OS and the input and output devices. The BIOS is also responsible for loading the OS into RAM in the long run. Now, after the BIOS has been activated, the computer is going to perform a post test, or a power on self-test. This is the first job of the BIOS, and it is to ensure essential peripheral devices are operational. So, if you ever watch a video about like someone who just built a computer, they're like, does it post? And that's like, does the screen turn on? Like, oh, there's an image on the screen. All right, that means the system is operational, or at least at the lowest level, it is operational. Windows may not work, but the motherboard is working, the CPU is turning on, the ROM is there, yada yada yada. So all of the lowest level hardware is in place and working, and we can see something, so we can start interacting with that. Often this information is stored in the CMOS, which contains information about the system's memory, types of hard disk drives, and other essential input and output hardware components. For those who do not know, CMOS is the complementary metal oxide semiconductor, and this memory uses almost no power at all. Oftentimes you will see a little coin cell battery on the motherboard, and that is to keep power to the CMOS. You also may hear of a CMOS reset, and if you're like, well, someone may say, well, if your computer's not working properly, reset the CMOS by either pressing this button or taking the battery out for 5 minutes, or whatever the state is. So that is basically saying, forget everything about how the system was configured. We're going to go find all this information again. So it's going to basically ping all the hard drives and go, is there something plugged in here? Yes. Okay, what's your name? You're this. Is there a mouse plugged in? What's the CPU being used? How much RAM is there? Yada, yada, yada. And obviously, having to fill in the information in the CMOS takes more time than having it pre-configured and remembered. So that is a very important part. After the power on self-test is complete and says, okay, everything is good, we start into the loading of the OS. Now, your operating system is always going to run out of RAM, because RAM is so much faster than a traditional hard drive. So we're going to take all the important system files and put them into RAM. This also looks for the system file in the pre-configured device list in the CMOS. So it's going, where should I be loading this information from? Hard drive A or B, or partition this or that, or one of those wonderful aspects. You may also see a boot manager, which allows you to pick how you're booting your computer. So if you have 2 operating systems installed on your computer, are you going to boot from partition A or B, or Windows 7 or 10, or should I go from the flash drive or the hard drive? Those types of things. All right. So that is either going to be part of the post or part of the OS loading, depending on which stage it is. So like booting from the hard drive versus a flash drive, that's probably part of the post. If you have two operating systems installed on your hard drive, that's going to probably be part of step 3, where it's going, should I load Ubuntu or Windows? Your system files do tell the computer what to load and where to load it in RAM, so it can access them. And once the kernel gets loaded into RAM, which it's always loaded into RAM, that's when the the kernel takes over running your computer. So instead of the CMOS or the BIOS running the computer at this point, once the kernel's loaded, that's when the operating system says, all right, I'm in charge now, and it takes over. Step 4, which is basically once the Windows is already, or the operating system is already running, it's going to check for further configurations and customizations. This is going to go into your registry and go, all right, do you have this background or that background? Do you like this font or that font? Or you have it left-handed mouse, right-handed mouse, those types of things. Or power management. Do you want a low power, high power? Do you want to sleep at 5 minutes or 10 minutes? So those are the types of customizations. That's going to be the last thing to get loaded. So overall, it's a 4-step process. So BIOS, post, load RAM, configurations. So kind of overall 4 general stops. And that will be the end of part 1 for chapter 5.